Welcome dear students. Today we will discuss the topic curve tracing in differential calculus. Generally we trace three types of curves. First, Cartesian curves whose equation is given in the form of xy. Polar curves whose equations is given in the form of r theta. And the third, parametric curve whose equation x represents by x is equal to xt and y is equal to yt, where t is some parameter. So first we will discuss the tracing of Cartesian curves. In the tracing of Cartesian curves, the following steps are used to trace a curve. First step is very important step, that we have to check the symmetry existing in the curve by seeing the equation of curve. The following types of symmetry can exist in Cartesian curves. First of all, symmetry about x-axis. See the equation of the curve. If all the powers of y existing in the curves are even, then the curve will be symmetrical about x-axis. See why the example here. The curve y square is equal to 4ax parabola, simple curve. Here y exists only one place and its power is 2, so it is even. Then symmetry rule says that this curve will be symmetrical about x-axis, and we know that this curve is this. Clearly, this is symmetrical about x-axis. Symmetrical about x-axis means the curve is same in shape and size on both the sides of x-axis. Clearly. Second symmetry is symmetry about y-axis. If all the powers of x existing in the curves are even, then the curve will be symmetrical about y-axis. See the simple curve. X square is equal to 4ay. See here, x exists here, only one place where its power is x square means power is even. So this curve is symmetrical about the y-axis. Clearly see this well-known curve is again a parabola and it is symmetrical about y-axis. Third, if all the powers of x and y both are even, then curve will be symmetrical about both axes. Or in other words, if replacing x by minus x and y minus y by, if the curve remains unchanged, then the curve will be symmetrical about both axes. Simply see the example, x square plus y square is equal to a square. It is a circle, center at the origin of radius a. So see here, it is symmetrical about the x-axis and the y-axis both. What is the use? So, the use of symmetry is if we trace the one side curve about the line about which the curve is symmetrical, then the shape and size of the curve will be same. See here, this curve is symmetrical about both axes. Now again, replacing x by minus x and y minus y by minus y, if the equation of the curve remains unchanged, then curve will be symmetrical about the line y is equal to x. See the curve, x cube plus y cube is equal to 3axy. Replace xy minus x and y by minus y. The equation does not alter, so this curve is symmetrical about the line y is equal to x. Okay, and the curve will also symmetrical in opposite quadrant also. These are the main symmetries which I have explained. And in the second step, we will check the origin of the curve. So put 0, 0 in the equation of the curve. If 0, 0 satisfies the equation of the curve, then curve will pass through the origin. And if 0, 0 does not satisfy the equation of the curve, then curve will not pass through the origin. So in second case, we tell nothing, but in first case, if the curve passes through the origin, that means 0, 0 satisfies the equation of the curve. Then we will find the tangents at origin. What will be the tangents to the curve at the origin? And it is obtained simply by putting the lowest degree terms existing in the curve is equal to 0. Note this thing. How we find the tangents at origin? The tangents at origin are found by putting the lowest degree terms existing in the curves equal to 0. By proceeding in this way, if we find two tangents which are real and different, then origin will be null. See the example, if the curve is x cube plus y cube is equal to 3axy. So the lowest degree term, putting 0, 0 in this curve, both the sides are 0. So 0, 0 satisfies the equation of the curve. So curve will pass through the origin. Now we find the tangents at origin, means the lowest degree term in this curve is 3axy. So put 3axy is equal to 0, means xy is equal to 0, means x is equal to 0, comma y is equal to 0. X is equal to 0 means y-axis, and y is equal to 0 means x-axis. And both of the tangents are real and different. So in this case, there will be a node at the origin. See in this curve, two branches, different branches passes through the origin and form node. And if in finding the tangents at origin, if we find the tangents are 2 in number but both are identical, then there will be a cusp at the origin. See another example, if the curve is y squared 2a minus x is equal to x cube, putting 0, 0 in this curve, both the sides are 0, so they satisfy the coordinates of origin, means curve passes through the origin, and the lowest degree term in this curve is 2ay square, putting it equal to 0. So y square is equal to 0 means y is equal to 0, y is equal to 0. When tangents are 2 in numbers but they are identical. So in this case, there will be a cusp, means the one tangent is common on both of the branches of the curve. What is the difference between node and curve? Node, the two different tangents will be at the origin of two different branches of the curve. But in the second case, if the cusp exists, there will be a common tangent to both branches of the curve. And if the tangents are 2 but both are imaginary, then there will be a isolated point will exist in the curve. So two important steps I have explained you. First is symmetry and all types of symmetry I have explained you. Second, study of origin, and then to find the tangents at origin. In the next step, we will find that the curve will cut the x-axis How? Put the y is equal to 0 in the equation of the curve. Equation will remain in the x. Solve this equation and find the values of x. If real values exist, then at that point curve will cut the x-axis. Then we will find the tangent at the point where the curve cuts the x-axis. Similarly, we will find that the curve will cut the y-axis or not by putting on the y-axis x is equal to 0. Put x is equal to 0 in the curve, the equation will remain in the y. Solve this for y. If the real roots exist, then at that point the curve will cut the y-axis. Then in the next step we will find the tangent at the point of intersection of the curve and y-axis. Clearly, in the next step we will find all the asymptotes of the curve by general method, or we will find the asymptotes parallel to the x-axis and the asymptotes which are parallel to the y-axis. For in the next step we will check the region where the curve exists or the curve will not exist. Put the curve, equation of the curve, y is equal to in form of x or x is equal to in form of y, and see in which range of x, if the value of y is imaginary, then curve will not exist in that region. And similarly, the range of y in which the value of x is imaginary, in that region curve will also not exist. And with the help of these following steps we will trace the curve. Now we will explain you this by some simple example. See here, we have to trace the curve y square 2a minus x is equal to x cube. This curve is known as seesaw. The name of this curve is seesaw. In first step, we will check the symmetry. Since the powers of y existing in the curve are even, so this curve is symmetrical about the x-axis. Second step, put x is equal to 0, y is equal to 0 in this equation. Both the sides are 0, so it means the curve will pass through the origin. Then we find the tangents at origin by putting the lowest degree terms equal to 0. The lowest degree term in this curve is y square. So put y square is equal to 0, means y is equal to 0, comma y is equal to 0, means the tangents are 2 in numbers, but they are identical. So there will be a cusp at the origin. Now we find that this curve does not intersect the x-axis except origin, and this curve also does not intersect the y-axis except origin. Thus, the curve passes through the origin, but it does not intersect the x-axis, and it also does not intersect the y-axis. Now put this curve y is equal to x under root x upon 2a minus x in this form. So if the value of x is negative, then clearly see here the sign under root inside the under root is negative, means the value of y is imaginary. So for all negative values of x, this curve does not exist. It means this curve does not exist in second and third quadrant. Now, if see here in denominator is 2a minus x, so if the value of x is greater than 2a, then this value is under the square root is also again negative. Means value of y is imaginary. It means the curve will also does not exist for all the values of x where x is greater than 0. It means the curve exists only in the region in which x lies between 0 and 2. In the next step, we will find the asymptote of this curve. Clearly, by seeing the curve, the asymptote parallel to the y-axis is the find the coefficient, the highest power of y 2 and its coefficient is 2a minus, so which is not equal to constant. So by putting this equal to 0 means 2a minus x is equal to 0 is the asymptote parallel to the y-axis. 2a minus x is equal to 0 means x is equal to 2a. So they see this line, this x is equal to 2a line, 2a is the line which is asymptote of the curve. Now for tracing the curve, see from the origin, since common tangent is x-axis, so two branches starts from origin whose common tangent is x-axis, and the curve is symmetrical about the x-axis, so shape and size of the curve above the x-axis will be same as below the x-axis. And x is equal to 2a is the asymptote. So this curve will touch the line x is equal to 2a at infinity, and using this we will find in the second and third quadrant curve does not exist, and for all the values of x for which x is greater than 2a, the curve also does not exist. So the real shape and size of the curve y squared 2a minus x is equal to x cubed, this solid is shown as in the figure. This is the simplest example of curve tracing. Now again another simple example I will tell you. Trace the curve y square a plus x is equal to x square b minus x. X square a plus x is equal to x square b minus x. Simply you see that all the powers of y existing in the curve is y square, which is even, so this curve will be symmetrical about x-axis. First step, put x is equal to 0, y is equal to 0, we get both the sides are 0. So this curve passes through the origin. And now put the lowest degree term in this curve is a by square is equal to bx square. So y is equal to plus minus under root b upon ax, means the tangents at origin are 2, which are is equal to y is equal to plus minus under root b upon ax. So two tangents which are real and different. So there exists node at the origin. See, means from the origin two different branches of the curve passes. For both the branches of the curve tangent for one branch, tangent will be y is equal to b upon under root b upon ax, and for second branch y is equal to minus under root b upon ax. And simply we will find the asymptotes parallel to the y-axis is putting the coefficient of y square, means a plus x is equal to 0, means x is equal to minus a. It is the asymptotes. And we also examine that this curve cut the x-axis, means putting y is equal to 0. So x square b minus x is equal to 0, when x is equal to b. So at point b0, this curve cuts x-axis and the tangent is perpendicular to the x-axis at this point. And using all these points, we will trace the curve, and the curve comes out in this form. This curve, see here. So we have explained to you today the tracing of Cartesian curves, and with two simple examples and all the steps of, I think you have understand. Study well, work hard, and do well preparation for the examination. Best of luck. Thank you.